Can you see my screen?
Feel free to post your questions on the chat. We'll keep answering that. And once the session is over, we can also have a Q&A. Yeah, Nag, please go ahead.
Yeah, well, thanks all. Welcome to Bangalore Virtual Meetup. Today we will walk you through different concept that is overview of event-driven architecture, why we need to use event-driven architecture or RESTful APIs in microservices. So what are the limitations and what are the benefits of event-driven architecture? And we also demonstrate the brand new Solace PubSub connector, which is official Solace connector available in AnyPoint Exchange with a small business use case. Yeah, these are the housekeeping rules. So the sessions will be recorded. So please be muted yourself, and we'll go to proceed. Yeah, the agenda is we will start with introductions of speakers and the organizers, and then Giri will start the overview of event-driven architecture, and myself will give a demonstrate of Solace PubSub connector with a small business use case, and finally we'll close with these remarks and the next meetup topics. Yeah, about the organizers, we have Rajesh, Prithvi, and Gaurav, and myself, and we have a recently joined Piyush. And about the sponsors, Solace and Mulesoft. Yeah, our our first speaker is Giri. Giri, can you please explain? Can you please give introduction about yourself?
Yeah. Yeah, guys. I'm Giri Venkatesan. I'm a developer advocate with Solace, and I have quite a bit of experience around integration space and EDA specifically, and recently spent some time with Mule Connector with the same team that's here, Nag especially. So I found an opportunity to kind of share the event-driven architecture, the foundation. What's it about, and how it kind of changes the landscape or enhances the landscape to solve more complex problems. So I'm here to share what I learned, what I know, and a bit of capabilities of Solace Mulesoft connector jointly. Right? Thanks, Nag.
Yeah, thank you, Giri.
So just to add one note here. So maybe you people would have known we have done one session on at AnyPoint MQ long back in 2020 November or October, and even before that 2019 we did one on Apache Kafka. So today we will go with Solace as one of the use cases for the EDA methodology and the MQ connection. Yeah, Nag, please go ahead.
Yeah, thank you, Prithvi. Yeah, yeah, this is Nagaraj. I currently work as a senior developer at Wipro. I have 4+ years of experience on designing, developing, and managing Mulesoft API. Especially, I started my career with Mulesoft and still continuing with Mulesoft. And I'm also part of the Mulesoft meetup leaders for Bangalore location, and I'm certified platform integration and developer. Yeah, over to Giri. You can share your screen and start with your.
We'll do that. Just a second. All right. I'm sharing the screen. Is it visible?
Yes, we can see Giri.
Yes. Hi guys. Again, this is Giri Venkatesan. I am developer advocate at Solace. I'm happy to meet with you guys as a community, growing community, very active community. Because I myself have attended a couple of meetups. So happy to be connecting with you. And I also thank the team, Prithvi, Nag, and Rajesh for inviting me to kind of share event-driven architecture overview from my perspective and introduce you to the AnyPoint connector. Thanks again for the opportunity. Let me get started. So today, what I'm planning to do is, lay the foundation of what is an event-driven architecture. Without getting into too much of detail on what Solace does, what the connector does. Objectively, what is an EDA? What is event, and what is an event-driven thinking or design, and how does the event-driven architecture came into existence, and what are the pros and cons, benefits, and so on at a very high level. So if I were to ask you a question, you want to be event-driven, what would be your answer? Feel free to put your messages in the chat. But I'm going to make an assumption here. The simple reason that you're here, it shows an interest, right? Obviously, yes, you want to be event-driven in your problem-solving methodology and your solution scoping and so on, right? Obviously, some of you might say that, I think so, because you're still learning. What the heck is this? Where do we go from here? We just moved from monolithic building to workflow to something new, right? So all those questions will get a bit more clarity, right, as we go through this session. So functionally, let's start with this question. What is an event, right? An event is something that happened or can happen in the system that is important to you. Each word carries its own weightage. So many things happening in your system, right? System coming up, or system sending out message, receiving a message, or restarting, and then logging, so on, right? But not everything is important. Only things that are critical to your application, your business scope, you would want to capture that and then treat that as an event so that you can send it across to somebody else who might be interested, right? So now that we are developers and architects, in our software terms, what would we say? An event is an immutable record that basically records something that happened within an application. So in the case of a database record is a state, right? In the EDA, it's basically an immutable record that captures information about something happened within the application. Fair enough? So this is the event. By the way, guys, my apologies if you hear any background noise. Suddenly something is happening around my house. So there's a bit of a road construction, whatever it is, I'm hearing some noise. Hope you won't get too much bothered about that. I'm going to assume that it's okay and proceed. I also have a request for Nog and Prithvi. Please feel free to interrupt me if there's a bunch of questions there that it's better off answering them right away instead of postponing, right? So feel free to kind of interrupt me. I will take a pause and take a look at that. All right.
Yeah, sure. And it seems you have a noise cancellation phone, so we don't hear any background noises.
Awesome. I'm glad. All right. So let's start with the question of why should we be event-driven, right? One way to justify something, what's the greatness about it, is to take this rhetoric question. Why should we be event-driven? Simple reason, the benefits, right? The first one is very responsive, meaning being able to quickly react in time, because every single interaction is going to be in real time, and the communication is definitely based on a low latency basis, right? So unlike our traditional methodologies of interaction between application to application or system to system, in EDA, it is a responsive communication, meaning real time and low latency. That's one benefit. And then the second one is resiliency, meaning there's no single point of failure. First of all, we are talking at a very high level, right? Only when you dig into EDA, you will know what are the components that makes up an EDA, right? The notions like broker, queues, topics, all those things will come in. Let's park that for a moment. In an EDA, right, if you are enabling communication between systems in the terms of sending across events and receiving events, is there a single point of failure? The answer is no. There is no single point failure, and then this failure tolerance and failover, whatever the way you call it, right? That's elegantly implementable in the EDA, right? And obviously, the most important in every system, right? Scalability. I mean, when you have the workload expanding, you would want your solution to kind of scale automatically. Similarly, when it kind of scales down or contracts, you will want to contract your load scope also, right? So if you think of this statement, obviously you can think of Kubernetes, right? So when you implement your requirements as a microservice, right? So you will need to scale the microservice based on the load. That's a given. That's why you choose Kubernetes. If you're using hardware, like a web server, then you're talking about scaling the web servers and putting some load balance in the front and so on, right? So the scalability is always a requirement, right? And these three are the major benefits. I mean, this is just a small set that we can all relate to. There's a lot more than that. And obviously, this gives you something more, which is decoupled and asynchronous interaction. Based on what we know as an enterprise architecture, right? The monolithic client server and every other form, there is a tight coupling, knowingly or unknowingly, you end up in creating between the components. By creating tight coupling, you increase the dependence, so the changes cannot be in isolation, right? When you create a decoupled system, that means these systems or these services can evolve on their own without depending on the other, right? And obviously, when you have a decoupled system, you don't have to have your communication on a blocking manner all the time. You can easily implement, or you can benefit from the asynchronous communication, right? We'll see more on this, the blocking versus non-blocking. That's what the asynchronicity is about. So the decoupling is one of the benefits of this EDA. We'll see more on this. Now, objectively looking at it, EDA has been around in various forms for the past couple of decades. It used to be called as message-oriented integration, message-oriented middleware, process server, ESBs, so on, so on, so on, right? Even integration server. And EDA is just a culmination of all these things to an extent that the focus is on low latency, high performance, and decoupled, scalable systems, right? But beyond that, there are certain forces that makes it more relevant and need of the hour. What are they? Now that, at least for the past few years, maybe a decade, we have been moving everything to the cloud. Simple reason, your solution building doesn't have to kind of inherit this load of managing all the hardware, storage, and networking that's required for your application, right? The birth of this as a service notion, infrastructure as a service, platform as a service, whatever you call, right? That gave rise to an opportunity to push everything to cloud. And in that model, again, you have hybrid and multi-cloud deployments. So basically, the more power to you as a application builder, focusing only on your business logic. You don't have to worry about the hardware, platform, scaling configuration, and so on, right? This became one of the motivation why EDA is more relevant today than before. And from a software perspective, right, applications used to be monolithic. We can call it as any kind of design. Popular one that we know last is the client server, right? From there, we moved to database-centric, batch-oriented systems, ETL-based systems, and so on, with all kind of proprietary protocols and APIs. And finally, in the past few years, we ended up having everything in open, meaning open source, open standards, open protocols, open APIs, and so on, right? So that means there's more players, more creative thinking is going into the problem solving. So this gave rise to a new opportunity, easily decompose larger systems, basically kind of a break up the complexity into collection of smaller solutions or microservices, right? So this gave rise to a new mode of a communication or an architectural design principle. That's where EDA came in. So now you have a real-time and the need to handle high volume, a whole slew of things gave rise from a software perspective to the notion of EDA. Now, a third point is about the SaaS and REST. In the early days, the web is all about serving static pages. Send a request, boom, you get a page, you view it, happy, navigate, move on, life is done. But in the past decade or so, we started moving more business critical applications to the web and various kind of protocols, especially with the RESTful, right? Now we are talking about meaningful application interaction. It's not just the client server serving static pages and images, right? And so this gave rise to the notion of kind of a need for advanced modes of communication. The reason is in the client server, typical RESTful, you had a synchronous as the basis, and it was always one-way communication. What we need with more complex and critical applications going onto the internet, right? So the need for efficient, asynchronous, and bidirectional communication became a must to have. That gave rise to a new set of protocols, open protocols, WebSockets, MQTT, AMQP, and so on, right? Last but not least, we are living in an era where everything is treated as things, except for humans. Maybe, if we are also full of things, meaning you have a watch, right? You have something electronic gadget, phone, right? So pretty much, the world is full of devices, which used to be dumb. Now they're all smart devices, starting from your refrigerator, doorbell, elevator, and so on, right? And without having this need of a wired connection, we have this 5G and 4G network. So there is an explosion of these devices, all of them wanting to connect to the net, wanting to communicate with each other, if not another central system, to the cloud, and so on. So the fundamental problem is, on such a scale, how do we address the need for routing the messages, scaling the applications that serve the business purpose, right? These are all complex problems that we never had before. And even now, we are evolving. And EDA just happened at the right time to serve these kind of a high volume, low latency, micro interactions. So to that extent, just note the number. We are going to have 41.2 billion devices by 2025. Imagine what kind of architecture is going to kind of fit into so. Last but not least, this is a graph from a Gartner's study, pretty dated one, 2019, but it is so good, so valid. When something gets generated, let's call it data, right? The moment it gets generated, it starts losing value. What I mean by that is, say, the data is captured and made available for you to process. The process is to analyze. Analysis is to extract some meaningful value out of it so that you can make intelligent decisions. If you kind of rewind the clock, maybe a decade back or decade back, you had this business intelligence systems, BI systems, right? So they used to get data on a batch basis, rolled up maybe daily, minimum daily granularity, if not weekly, and so on, right? So that basically that era we were doing historical data processing that gives certain intelligence. That's a traditional approach. Then we said, no, we don't want reactive. We don't want historical. We want reactive. That means we need the ability to capture the data, process the data, meaning analyze the data, and then extract the insights that you can act upon, right? So that's a reactive. That means you need to process data within seconds or minutes, right? And then further advancements happen. As the data gets generated, it gets analyzed. Actionable intelligence is extracted out of it. That gave rise to the actionable intelligence. And last, we are in this era, we are talking about real time. Obviously real time, as in there is a latency of sub 100 millisecond, maybe 30 milliseconds or something, depending on which cloud and the proximity and network connectivity speed and so on, right? But today we have the ability. In real time, we can capture these data as they get generated, analyze, and produce intelligence. And this type of intelligence is predictive and preventive, which is what all the businesses wants, right? If there is a supply chain problem, you don't have to wait for a day or a month to figure out that there's going to be a problem in the supply chain. You want that intelligence to kind of identify what is going to happen to my supply chain. Maybe inventory will run out, or maybe the supply route will be disrupted, or maybe I need to have an alternative planner, somebody, right? So those kind of decisions need to be made in real time. That's the era that we are living in. And event-driven just precisely answers these needs, or at least it aids you to get there with ease compared to other approaches that you may have, right? In all, we are talking about basically distributed applications or distributed services, right? Let's take a simple example. We have a need to move data from A to B, right? In a old school thought, you would have said, oh, put it in a FTP, I will pull it. Or maybe put it as a file and send an email. All those things are done. What if you have a need, A is sending something to B, that's what you know today, but tomorrow C comes in, hey, I'm also interested in the same data. Now, if you end up in treating this requirement as a point-to-point communication, then you would have to repeat the entire work, be it infrastructure or be it a service. Whatever that you have done for A to B, you need to repeat for A to C, right? So this makes it complex. That's where the event-driven comes in, saying that whatever that you need to share, either as a command or a document or an event, just publish it. And anybody who's interested can subscribe to it. I'm just saying a very high level, right? The old school thought or approach that still some places it's useful or used, file transfer, shared database, TCP socket, SOAP, messaging, and so on, right? Those are all valid, but it cannot scale. Why do we need to stop at C? How about D? How about E, right? Or how about, I don't know, whoever comes, they should be made available to them. So the evolution of the business need resulted in evolution of the integration, right? And that's the culmination, what we call as an EDA, event-driven architecture, is an integration solution offering you highly scalable, real-time, low-latency communication between systems. In turn, I would even go to the extent of microservices. It is well suited for microservices. A quick quiz for you guys. If I were to ask you the question, EDA, or rather, if I make a statement, EDA is for high throughput use cases only. What would you say? Is it a fact or a myth? Just put it in the chat, please. Yes, no, or fact or a myth, whatever that you want. Yeah, that's nice. Awesome. Awesome. I think the majority goes with the myth. I like it. Simple reason is um, it is a myth. That's correct. EDA can be used for mission critical communication as well, where there could be a single message triggering a bunch of other messages. So it is not necessarily for high throughput cases, right? It's the criticality of the business requirement about guaranteeing the message or event passing from point A to point B, mediated through broker, and so on. Okay, so it's good. Thank you. Second. So at this point, before diving too much deep into the concepts and components of EDA, what I've done is, let's take a use case. There's something that we have at Solace to demonstrate this EDA notion, a dragon boat race, right? In that dragon boat race, there'll be 4 teams, up to 100 plus players can join, right? And randomly, the algorithm puts each of the user into a team. And this basically has a front end. That's what we'll be interacting with. And it can be accessed from mobile also. So when somebody joins, they'll be put in a team. So at the end of this, whatever time that we wait for, there'll be 4 teams. And each of the team can, once the race starts, can tap on the phone, or if you're opening from a browser, you can click on that web page. So behind the scene, these clicks and taps are converted into motion of your boat, whichever team that you belong to. Whichever boat it reaches the endpoint, they become the winner. It looks like a fun game, right? But believe me, there's a lot of EDA definition that we can extract and then extrapolate what is it being done, how it will be done with other opportunities, how EDA stands out to solve this problem, and so on. So with that said, I'm going to share this screen. Just a second. Okay, so all right, you can see the screen, right? So there's a QR code. If you're joining through mobile, please scan the QR code. It'll show a URL, and I'm pretty sure it's going to open in the browser. If you're coming through just a computer, laptop, just go to this URL, sg.solace.com/db, and then join. So you can see here, 2 people join, and the algorithm has already put them on the different teams, pink, green, yellow, and orange. Yeah, go ahead. There's a lot more interesting things that we need to talk about. If you want to, please act on this rather quickly.
Yeah, guys, this is really interesting. Let's go and join this, and let's play this game.
Yeah, it is a game. Don't worry about EDA for a moment. It's just a game. Yep.
And Giri, how can I know which team I'm part of?
You will get to know. When I start the race, it'll identify you with the color.
Okay.
I'm sure you should have seen this. No, you're not seeing it?
Yeah, seen it, but not very clear on it.
Okay, let me just see if I can join as well. .com/db. Yes. Okay, you are on green team, right?
Oh, okay.
So you must have gotten some update like that. Okay, 30 people joined. That's good enough. Hey, thanks, guys. So I'm going to click on this screen window. Basically, this is the controller, right? I'm going to start the race. When I start, all of you will get a broadcast saying that the race is starting, and it'll ask you to start tapping or maybe start clicking, either way. So on your marks, get set, go.
Let's row our boats.
Yep. Come on, guys. Tap or click, either way. All right. Looks like green and red are okay. Yellow. Green is leading the effort. That's awesome. Come on, come on. Tap, 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 tap. Multiple taps. You can use 2 fingers, 5 fingers. Doesn't matter. There we go. You will figure out a way to lead. Okay, pink. Oh my God, yellow. Where did you guys come from? Awesome. Awesome, awesome. Okay, so here it is. So the race is over. First metric is the LO team one. That's great. The most clicks by any individual is 190 clicks. And second most is 189. Third most is 132. Worst clicker is 0. That's me, most likely, because I have the window open, didn't act on it. All right. So behind the scene, if you notice, there is going to be information about who clicked. Okay. You would have seen, if you are the top guy, then you are the most clicked one. So if you check your screen, you will know who it is. I wouldn't be able to tell you unless I go and look at the backend data. So this is just a game. Remember, we just started the race. There is a controller, there is a client. You guys are all clients. You joined the race and you started clicking, and all those things are getting consolidated. Meanwhile, these clicks are also getting transferred or informed to your client application, and you see the boat race being rendered in real time. And when the race was complete, we have a winner and we have metrics. So this sums up pretty much what happened in this Dragon Boat race, correct? Okay, now let me get back to the slides.
So if we correlate this to our normal HTTP calls, it's basically the number of transactions that you get into your listener.
Yes, your thought process is perfect. That's exactly what I'm going to talk about. But I would put it as in this way. Let's see here. What we just saw is event-driven in action. But if you need to dissect this, what happened, to kind of provide such a thing, first, traditional knowledge, right? We need to have a web server to host the components. What are the components? The controller landing page, and then your client Dragon Boat landing page, right? And then the race controller interface to start a race, and then the algorithm to assign these things and communicate that to the client, and then a race display for the participants. This could be a standalone application or it could be combined with a controller. And last but not least, the front end, right? I could be coming through a browser or it could be a mobile. So there is a possibility of using JavaScript or Android, iOS app. And you can expand, if you have a different kind of front end, you have different things, right? So this is what we have done, right? Now, what we would do if it's not for ADA, we would have picked up our most popular one, REST over HTTP, right? Does it fit the bill? The answer is yes. But is it perfect? REST architecture is client server by definition. That means there is one server, multiple clients. That's great. And the communication is REST is always over HTTP, and it is point to point, right? If you guys have any contention, any question, or any argument on this, please feel free. HTTP is synchronous protocol. I'm just stating what are the facts about REST over HTTP. These are all good, but as I read the statement, you can see, oh my God, it's over HTTP. It is point to point. Point to point will not work. We need a different kind of systems, right? I will justify these assertions in the next few slides, but is there any alternative mechanism for the REST? Answer is yes. I'm proposing an event-driven system can serve this well, even better, right? Okay, when I say event-driven system, first thing that could come to your mind is, oh, Kafka. That's great, but Kafka is not bidirectional. Remember that, right? Or can it do request reply? The answer is no. Kafka is also an event-driven system, but it serves a streaming purpose, which is slightly different from EDA or PubSub, right? So I will not go into that detail, but let's take an issue. The first issue that I see, if we were to use any architecture for solving this Dragon Boat, we need the ability to discover the service. What is the service here? A race, right? How is the race identified? By the title. When you join, hey, do you want to join DevJam race, right? That's a race name or identifier. So parallelly, I could be running another race with a different name. So I can have multiple races that are ready to go simultaneously. And each race can have 10 to 100 people. Imagine if I have 100 races and each of them have 100 participants, there itself I have 100 by 100 nodes or touch points that need to interact with the server, right? So dynamically starting and stopping multiple races. How do I do that? Could I have another component that's centralized and then exposing this as a discovery service on all the client, come and talk to that, and then, hey, is there any race going on? I can do that. But is that the best way? I'm not going to answer the question. I'm just seeding these questions in your mind so that you think about it, and we will review and revise this after going through the EDA depth. All right. Second question, how do I signal the start of the race? It's not like a single client server. There are hundreds of client nodes, right? All of them have to get the start command at the same time, simultaneously. Imagine if you use a REST, what happens? There'll be latency, and the HTTP over is not the best performing, what do you call, latency wise, right? And typically what we know is client server. That means clients initiates a request, server response. But over here, once everything, if you notice, it's mostly server to client. The server is the one telling, hey, race is about to start. Server is the one telling you are in this position. Server is the one that's telling the race is completed and this team has won, right? It looks like a client server, smells like a client server, but it is actually, if you look at it, it is more of a server to client, right? So how do you do this? Traditional thinking, oh, I'm going to do a poll. You know what happens with a poll, right? It's going to kill the system. You will die by timeout. And then each player, what if each player runs a web server? Does it make sense? Is it even possible to run a web server on a form factor like a mobile phone? Doesn't work, right? So there is an issue, something to think about. How do we signal the start of the race? Third question, if I were to ask, everybody was tapping. Right? As you're tapping, you're not just seeing your progress, but you're also seeing other teams' progress in your screen, correct? When you're looking at it, what really happened is everybody's row, which is an event or event equivalent, that need to be broadcast to everybody, right? So would it make sense to have that row from your phone to the server, and then server sending it to everybody else? That's a possibility, but is that the efficient one? Or does it make sense for the phone to send it to everybody on a broadcast channel? That's a possibility as well, right? So what we need is a very, very low latency solution, so that when I tap, that tap should be reflecting on everybody else's at the same time, right? So just mark this. How do we achieve this? Obviously, you can clearly see the REST and HTTP slowly falling off the grace, because it is not meant for this kind of requirements, right? So the last one is, how do you enable communication? Right now we don't have, right? What if it's a serious game and a red team, if you're a gamer, you would know people would be kind of talking to each other, chatting with each other, strategizing what's the next move and so on. So in a real world game, if we need to use something like this, how do we enable inter-team communication, right? It is not REST anymore. We are talking about something else totally. Networking parlance, you would know this unicast, multicast, broadcast. Those are the things, we cannot deal with that low level. We need something at application level. And what if we want to do analytics on this? When I say analytics, not the traditional one. Okay, capture the data, run it through batches, tomorrow morning analyze and produce a report. No, real-time analytics, right? So how do we do that? All these events, the tap events and joining events, leaving events, winning, all those things to be captured, and insight has to be generated, and the insight need to be served back to the participants so that they make a wise decision, whatever they do, if there's involving making strategy and so on, right? So capturing all events for later analytics. The later could be next moment or next day or next game, whatever, right? So there are some limitations if you choose to use REST, HTTP, or something similar to it to kind of build a solution for this kind of a game, right? So we will analyze them, but before we go there, let's get into the EDA game first. Let's kind of event-driven is just not a technology alone, it's a thinking. When you are asked to solve a problem, right, there's a methodical approach that we take to kind of dissect the problem. To basically, that's where we start, right? Kind of break the problem into smaller problems so that the complexity is manageable, and then solve each of them, assemble them, and then go bottom up or top down, and eventually solve the bigger problem, right? Something similar to it, when it comes to EDA, there has to be a paradigm shift. You need to start thinking in the terms of events, right? So what is it? Let's start with this one. Events are everywhere, right? You play a game, obviously everything is an event. Even in a browser, if you have done any kind of UI programming, the event term is very familiar to you. A click is an event. right? Expand or collapse or browse, color change, button click, everything is an event, right? So there's no argument there. If you're a gamer, I don't even have to say anything. You very well know that every action of yours is an event. In real world, a credit card swipe on a machine, swiping machine, that's an event, right? And generate a bill, that's an event, or send an email, that's an event. So events are everywhere all around us. Now, to get more clarity on this, let's put some more skin on this one. We have been learning programming languages and we have been using programming languages for a long time. One of the evolution happened is we started thinking in terms of patterns, right? Once we see a pattern, or once we see that a pattern is fit for this particular kind of type of a problem or solution building, then it becomes a predefined knowledge. If you go back in time, we used to have something called as libraries, standard template libraries, reusable libraries. Those are all basically what? Same problem repeats itself, manifests itself in different form, in different problems, different requirements. So I'm going to build a reusable aspect. So the reusability has a particular interface, input, output, right? Something evolves as a pattern where you can repeatedly use the same knowledge that you acquire. When it comes to EDA, the thinking can be organized around these key patterns. From a programming perspective, there are two patterns you might be familiar already. If not, we'll just walk through it: observer pattern and reactor pattern. From an architectural perspective, the publisher subscriber pattern. That's the essence of EDA, right? PubSub is EDA. Of course, it's a lot more than that. But from a pattern perspective, architecturally, publish subscribe is what we're going to go after, right? At this point, remember, first question that we ask is there a better solution to enable this server to client communication or client to server communication, right? So client sends a request to the server and server is executing it. When it completes, the data becomes available, right? But how would the client know? Client can keep polling, right? We know the polling is there and it's been used. There's a regular poll and then there's a long poll, intermittent poll. There's so many techniques evolved around this polling notion. But in essence, it is bad. That's an acknowledged fact. We all know that. It's like if you watch Simpsons serial, the kids will be annoying so much that, are we there yet? Are we there yet? That's life, right? We don't want this. Could there be a better approach? Yes, that's where the observer pattern comes in. So let's identify the problem context with the two terms. There is a subject which is going through changes, right? And there is an observer who's observing the subject about the changes that's happening. So the observer is interested in knowing the change, the details of the change as it happened or immediately after it happened. So if this is the requirement, what would you do, right? Using the observer pattern, the observer basically goes and records the interest, saying that, hey, I am so-and-so, I am interested in knowing the changes happening on this subject. So basically it registers something what we all know, a callback, right? So the callback's a register, right? The subject takes the ownership of notifying these observers by invoking the callback whenever a change happens. So bottom line is, instead of the observer polling, now he delegated the responsibility to notify to the subject itself. It's the opposite of polling, right? There is no poll, there is no resource blocked, right? So when the change happens, as long as you have a registered callback, subject is going to notify you. So instead of a push, it's instead of a pull, it's a push model. Got it? So this is the foundation for an event-driven design. Just to be familiar with this one. The next one is reactor pattern. Reactor pattern is basically, if you have done client server, you would know that when a request comes in, till the request is served, the thread will be blocked. It could be the main thread. That means the main application main thread is unavailable to serve other requests. To overcome this, this is not an overnight thing. There's so many programming languages that's built around this construct, event loop, especially Node.js and so many modern, even the progressive web apps. Web technology extensively uses this event loop as a concept. And with that, every time when a request comes in, it spawns a worker thread, and worker thread takes over the actual processing, right? And when the worker thread completes, it calls back the main thread, which in turn call back the response. So essentially, you always keep the main thread open, available for serving other requests, right? This is a very critical pattern. And last but not least, This is the most important one. That's why we are here. Publish, subscribe. Bottom line is it is very much similar to the observer, just that it decouples the subject and the observer. Okay, if you ask the question, when did the coupling come in, right? Remember when I said the observer registers a callback with the subject. That's how subject knows that, hey, there is somebody interested in monitoring the changes. So I just need to invoke the callback. So that creates a tighter coupling, right? That coupling is blown out here. So the decoupling happens between the subject and observer. How it happens, we'll see more, but in essence, the publisher, the terminology is, we used to use client and server. If you turn it around, there is a publisher and subscriber, producer, consumer. At the end of the day, that's what it comes down to, right? There is a initiator, there is a responder. There's so many terminology. So the publisher publishes an event on a topic to the broker, and the broker is the one that maintains all the registered interest for the topic. Basically, the consumer is interested in the topic. So when an event comes in on the topic, broker distributes, publishes, or rather delivers it to the consumers. All right. So there's a lot more than just a simple PubSub, especially when it comes to Solace. If you take a single broker, yeah, it makes sense. There's a publish, there's a subscribe, there's a queue, there's a topic, all well. But Solace offers more than that. There's a notion of event mesh, which gives you the dynamic message routing, scalability. There's a lot more. So that's why we call it as a PubSub plus, right? The plus is always more. So just to briefly on the Solace PubSub plus, the way to look at it is it has a component that's meant for design time, which is event portal. Today, when you go through the demo, you would get to see a little bit in action around that. It gives you a governance framework for you to define your EDA. Your application domain, maybe if you take a traditional ERP, okay, my billing system, invoice system, shipping system, and so on. And then within that, you have applications, billing, credit verification, credit rejection, whatever, right? These are individual applications. And then you have events, credit passed, application rejected, or fraud detected, right? These are events. And within that event, what is the payload that you're sharing across, carrying that business data? That's your schema. So the whole design time aspect is covered in the event portal, as in you'll be able to design your EDA. That's the first part. The second part is a runtime, right? So after having defined the events and the applications and so on, now you should be able to publish, right? When you publish, obviously, if you publish to a single broker, that's your single point failure. So you need a scalable, resilient system. So you create multiple brokers, create clusters, create mesh, basically your runtime, right? That's where your EDA is running. You design the EDA and you deploy your EDA. Fair enough? So I will pause for a moment here. Any questions? All right, no worries. Thank you. Okay, so another question, a fun quiz. EDA can prevent cascading failures in a microservices architecture. I know if you're not familiar with the microservices, that's okay. It's just a component, deployable component. All right. I'm sure you must be. Just take a call. Is it a myth or a fact? Aditya says fact. So I'm reading the statement again. EDA can prevent cascading failures in the microservices architecture. Take a wild guess. There's no right or wrong answer. Anybody else? All right. That's good. It is a fact, right? It does offer the ability to prevent this cascading of failure scenarios. That's one of the issues with our traditional approach. I'm going to throw this terminology here. You can look it up later. Choreography and orchestration. When you say orchestration, it's an end-to-end from the service start to service end. It can go through multiple hoops, multiple components, but it's all one flow, right? And then the choreography, it's a tree. You drop something, it can take a different path depending on the flow. When I say flow, meaning the publish, subscribe configuration. We'll look into it in the next demo. So briefly talking about message exchange patterns. Now that we have the EDA basis done, it comes down to what you do in the EDA, right? We are going to need these three types of interaction. A point-to-point interaction. That means there is a producer, there's a consumer, directly point-to-point, one-on-one. And then there's a publisher. There is a publisher which publishes on a topic, and there are a bunch of subscribers who have registered their interest in receiving events on that topic. That's a publish subscribe. And the last one is request reply. I'm very confident, you guys being Mule, AnyPoint, workflow, all those things. These things are very familiar to you. This could be just an element in your flow design, but EDA is all about focusing on these elements, abstracting out for scalability. It's a deal by itself, right? So the request reply is basically you send a request to the broker delivers to the processor, whichever is ready to serve the request, and whatever the response comes back, it'll come back to the requester. Okay, so this is a request reply pattern, right? Since we are in EDA, obviously it doesn't make sense to talk about point-to-point. Point-to-point creates a tighter coupling, or at least it's not the best practice. If you are building an EDA system, you design your entire system around PubSub as much as possible, right? But it's not a no-go for point-to-point. You can choose to, but it's not best meant for it. The reason is, if one of the point-to-point service provider fails, implementing the failover becomes still a responsibility on the client side. All right, EDA cannot do anything over there because you have a microservice. That instance dies. That means all the messages will be dropped, not processed, right? If you want to bring in failover, then you have to have the ability to have a Kubernetes or some other means of detecting the service failure and launch one more service. If not, launch multiple services and put them in a active passive. That creates more load or responsibility and complexity on the client side, right? So PubSub is much more straightforward. Launching multiple instances simultaneously and all of them connecting to the broker, subscribing to the same topic. When something comes in, everybody gets it. Now, this gives rise to a new type of patterns of processing. For example, if your event flow is 1, 2, 3, 4, 5, 6, 7, you can do a load distribution between these instances. One goes to the first subscriber, 2 goes to the second one, third. You can see that round robin, right? And request reply is as good as what we discussed in the last one, right? There's one variation is if you're having a request reply is again one-to-one. There is a requester, there is a replier, right? The communication is intermediated by the broker, all well. But what if the replier wants to broadcast the reply? Basically, it's reply to many. I'm not going to respond to the same requester. Rather, I would publish the reply. So anybody who's interested in that kind of a reply topic can consume. These kind of thinking opens up new variations, and that can serve specific use cases. I'm not saying that this use case is valid in every business requirement. There could be cases. There are things that you might know: adapter, connector, processor, right? So some of them may require a variation like that. So coming down to the nitty-gritty details, a message is basically a package of data. Part of it is the header and properties followed by body. What does the header contains? Header and properties are something that's not packed. Okay, it's readable. Without breaking open the payload, you can get the information about what the message destination is, what's the delivery mode, what's the return address, if it was a request reply, and so on. And then any other business properties that you want to set that's specific to that message or the origin, you may set it as a property. So you could see somewhat resemblance between this and JMS. If you have worked with JMS, pretty much everything is same, just that there's a nuanced variation, that makes it more specialized for various functions. For this package, this semantics is very meaningful in Solace because we put a lot of custom properties in the allow you to put custom properties in the header and the properties, right? So you can build your own business logic without having to open the body. The body could be a complete binary data, byte array, right? So now, when it comes to quality of service, obviously there are two distinct types. This must be a question in your mind already. If you use broker, if you say it's going to be stored somewhere, it's going to slow down the system. The answer is yes, to some extent, but not necessarily completely slow. But if you don't want to store anything in the broker, you just want a pass-through, direct messaging, right? So you publish a message, the broker gets the message. If there are no subscribers, just drop it, forget about it. If there are subscribers, deliver to them. So basically, you're not going to store and forward in the future when somebody asks for it. That's the direct messaging. All right. No. Even if I'm disconnected, I want my messages to be stored and made available to me when I reconnect. That is the guaranteed messaging. When you connect as a guaranteed receiver or a subscriber, you will be creating a queue in the broker, and you will be adding appropriate subscriptions, the topics that you're interested in, to the queue, right? So now, as a subscriber client, whether you're connected or not connected, immaterial. Any messages that are published on the broker on that subscribed topic will continue to be accumulated in the queue. As a client, you can come back anytime. You can stay disconnected or come back later or connect now. All the events are going to be made available to you. All right. Um, these are all great. Now, the essence of EDA is about message routing. When I say routing, meaning between the publisher and subscribers, who's going to get what, right? If you ask that question specifically, the answer is through the topic. That means when you publish an event or a message, you are publishing it to a topic. All right. So when you publish to a topic, that is a destination. Now, if you need a guaranteed delivery, this is very specific to Solace. You will be adding a subscription to the queue, and then the broker puts the event in the queue. If you are a simple subscriber, you would be simply subscribing to the topic. You may not need a queue. That's a direct subscriber and guaranteed subscriber that we saw in the previous slide. All right. So this is something you will have to know when you use the connector, because the quality of service is how am I connecting with the Solace broker. Nag will talk about that more. So talking about topic, basically here's what it is. A producer sends a message on a topic, and broker opens the message, not the body, just the header and properties, finds out what topic the message is coming in on, and then it maintains a list of subscribers for the topic, identifies the consumers who have subscribed, and just delivers it to them. All right. So it's a topic-based routing. Okay. I'm going to skip this part. Sorry about that. So technically, if you were to ask a question, what is topic, right? So when you say something, okay, broker, yeah, obviously there is a broker as a resource exists. You can provision it, you can deploy it. There is a queue, yes, it exists. You can create a queue. There is a subscription, you can create it. But when it comes to topic, it is not a resource, meaning there is nothing you need to do to create a topic. Topic is an abstract concept. When you are about to publish, on the message, you say, I am publishing to this topic. To that extent, you can have any name for the topic. It doesn't have to pre-exist in the broker. So in the Matrix movie, Neo gets a fun dialogue from the kid, right? There is no spoon. In fact, the spoon is bending in front of him. Something similar. There is no topic, but topic is essentially the way you route the messages, right? So here's your topic. Basically, it's defined by the publisher. It is found in the property of the message, and each of the message can have its own topic, right? So you are a publisher. First message you could be publishing on topic A. It's not necessary that you have to publish the next one on topic A. No, you could be publishing on topic B, and so on, right? Now, pretty close. If you look at it, our topic is just a string, right? But we have a logic within that string notation also. It's a hierarchical structure. That means it's made of one or more levels, and each of the levels are kind of delimited by this forward slash. So if you were to connect to this quickly, you have a file system. When you say PWD, you get to see these directory levels, right? So there we use the right terms: directory level, directory name, and then sub whatever, right? So you get the picture. So something similar to it, what we are using here. Here's an example. There is a foreign exchange trading platform wants to publish a message. This message is meant for kind of a conversion rate between currency and currency 2, right? So the hierarchy goes, the entire string is, for example, whatever you're looking at here, right? The FX stream, NY4, feed to spot, real-time, euro to USD. The entire string is a topic. But within the topic, if you delimit, if you kind of split this by delimiter slash, now you get to know the levels. So on that basis, you can see the first level is application, that's FX stream. Second level is venue, which is New York 4. Third level is feed. Fourth level is what type of trading it is. Is it a spot trading or night trading? And then quality of service, real-time, batch. And then the source currency, which is euro, and converted target currency is USD. right? So this is just a topic string that can be found in the header. But really what is getting exchanged, what's going in a message is in the payload. The broker doesn't touch that. Whatever the publisher puts, it's going to be made available to the subscribers. And the broker doesn't operate on that. All right. If you want that to be operated, that's called as filters. You can do the filtering, but I will park the discussion. The topic-based routing is a very crucial one for Solace PubSub. So make a note of this. You understand this hierarchy notion, right? It plays a huge role. I'm just going to skip some of the things. Another example would be, we'll be seeing another demo. Let's say there's a lot of real-time data made available in smart city situations, right? Singapore has opened up its whole entire bus transport network data as an open data, okay, in real time, right? So the data, whatever format they made it available, what we could do is we can publish it based on this convention, bus track, that's your application, and what type of update we are talking about. There could be different type of updates. We are talking about the location, GPS update. So what other option could be there? Maybe service update. I don't know, right? GPS update, bus number, route number, and then the most interesting thing is the level 5 and 6, the latitude and longitude. All right. Now notice that it looks like a number to you, right? 045.3895 blah blah. Yes, it is a number, but it is not a number. It is a string. It looks like a number, but it is treated as a string in that level 5. How does it help? I'll tell you. So before we go to the demo, what you're looking at is being hierarchical. The topics provides you a taxonomy, ability to build a taxonomy. I mean, if you build enterprise systems, right? So having a hold over the governance is very important. What kind of topics you're creating and what kind of hierarchies you maintain. Based on that, you may have rules. Who can subscribe to what? Who can publish what? And then what type of access control you want to define for a particular domain or a category and so on, right? So this leads to the notion of how do we bring in governance in an EDA, right? So the topic taxonomy is critical, which is based on the hierarchical ability in the topic construction, right? Oops. So graphically, if you were to view the taxonomy, this is how it looks. In real world, we have even more complex taxonomies, but visualizing this taxonomy will get you a perspective of how granular you have defined your EDA system and how granular your data gets exchanged in your EDA. All right. This is all good, but obviously the question is when it comes to routing, you showed me an example, everything hard coded at each level. That is true. The question is, if you ask the question, do we have support for wildcards? The answer is yes, right? So here's an example. When do you need wildcard? So when a subscriber, you have 3 subscribers, A, B, C, and B and C, you can see in the list, right? They are subscribing to very specific topics. Now you have a publisher. He's publishing on topic 02. You notice only client B and C will get the message, not A. So the broker's kind of a job is to primarily to maintain the subscription list and process the incoming messages to identify the topic on which they are published on and deliver only to those subscribers whatever the message that's published, right? Now, the topic routing is what we saw in the picture, right? Now, it's a hard-coded topic name mapping. What if we don't want a hard-coded topic string? Rather, we want a wildcard. So there are 2 types of wildcards that are supported. One is star, that is for any value in a particular level. All right. So you go back to your Windows or Unix, ls minus l star, you will get everything. ls minus l s star, that means anything that starts with the alphabet S, right? Something exactly similar to that. It can be a standalone wildcard or it could be prefixed with a string. Second one is multi-level. What it means is, hey, give me everything from this level downwards. For example, in the ls, you have this command called ls minus lr, or uppercase, which is recursive, right? You may be in the root directory, but simply just typing ls minus lr, you are requesting the ls to recurse through everything under that level, give you the listing. Something similar here. I will show the example. It will become more clear. See, what you're looking at is FX stream, the foreign exchange trade we saw, right? The second one, if you notice, FX stream NY4 and then greater than symbol. That means anything that gets published by the FX stream application on the venue of NY4, give it to me. It could be a spot feed. It could be a euro or a dollar, whatever it is. We don't care about what's going in here. You see what I mean? How do I do this? Yeah. So the next one is we are looking at a star. The star is any value in that particular level. That means, can I say that, I'm going to get only NY4 in the second topic subscription? The answer is no. Because second level, which corresponds to the venue, you're having star. That means it could be anything. And you are using a star for the secondary currency. That means if you were to verbalize this thing, this is how it is. Hey, I want all real-time spot prices on euro versus anything, regardless of the venue. That's a rule that you get, right? That's a business analyst requirement. When you translate that to the routing, basically the topic subscription, this is how it translates, right? Hope you got a picture. If you have questions, please make a note. We'll talk about it when we get to the end of the session, right? Here's an example. The GPS coordinate that I talked about, right? So 045.3 star. Now you'll be wondering, what is the meaning of star in a GPS coordinate, especially latitude and longitude? Here's the answer. GPS coordinate is so, what do you call, granular. It can go to multiple digits. Each change in that nth digit, like for example, 39999 versus 0.4. It could be covering at least 10 kilometers or maybe more, right? We're talking about such a granularity. There's no limit to this, right? So the point is, if you say 0.3 star and 0.7 star, now we are talking about like a virtual fence, a bound. It's almost like a square. In the next picture, we'll see what's happening. Here it is. You see this rectangle, right? The 0.7 star is basically 0.7 to 0.799999, whatever it could be, right? And then 0.3 star is 0.3 to 0.399999 before it gets to 0.4. So essentially, if you were to plot these two bounds, you'll be looking at a rectangle, right? So within this rectangle, now you have an opportunity to visualize or track only the buses or whatever it is in there, right? So let's quickly switch over to bus demo just to highlight the what do you call? Okay. All right. Okay, here it is. So and this, what you're looking at is, there's a standard rectangle that's drawn out here, and every single green dot that you see is a bus. All right. This is again Singapore real-time data, and you can see this is the thing that we discussed in the slide, right? Bus track, GPS version 2, route number, bus ID, latitude, longitude, the direction, and status, right? Pretty much all the high-level information. If it's not for this kind of semantics, you would be putting them as an attribute inside the payload, right? Now we have an opportunity to promote that as part of the topic, and without opening the payload, now you are able to control who's going to receive this. This is what gives you the high performance that one would care for in a real-time application. Now, if you notice, obviously, let me just quickly. Sorry. It's a very interactive map. Just make a note of this URL and you can give it a shot anytime you want. So I just drew a bound, right? Random, maybe a rectangle, polygon, anything you want. So what I'm saying is, show me only the buses or plot only the buses whose GPS coordinates are within these bounds. If you're wondering why there are so many smaller cells here, because remember, this is a polygon. If it's a rectangle, like the one I showed in the slide, you can have 2 points, 0.3 to 0.39999 and 0.4 to 0.4999. So you can create a rectangular bound. So one subscription with wildcard would cover that. But over here, we have an unorthodox shape, right? It's polygon. So in this case, how do we do it, right? So mathematically, algorithmically, we can divide that into smaller cells, and each of the cell will represent it. For example, notice that when I mouse over, this one is 0.390 star, and then on the longitude, it's 0.88 star. I'm just moving one cell above, right? Notice that it's 0.391 star. So you're controlling the subscription. So that means any bus entering this zone, this rectangle, would have a coordinate that fulfills this routing wildcard, topic wildcard. Then it gets plotted, right? So it's more of a fun. If you get to expand this, you will get to see the real Singapore in action, right? So the key highlight is we should be able to visualize only those buses that satisfies the criteria. Our criteria is basically the shape that we want to showcase, right? Or maybe remove all shapes and put a circle. Where is the circle? Yeah, here is a circle. So you can see here. So slowly you can see all the other buses will vanish. Only the buses in that vicinity, this circle boundary, basically geofence, right? So I'll stop here. If you have questions, put it on the chat, or we will catch up. Make a note of the questions. Let me get back to slides. I have very limited time. Let me brush through. Basically, that's what I have to do. All right, one more question for you guys. Event streaming solutions are only implemented using Kafka. Is it a fact or a myth? What do you think? Nice, nice. So no, I'm super happy. You guys have spent quite a bit of work around the streaming and events. That's great. Yes, it is a myth, right? You have various ways of implementing this streaming, right? Now, when it comes to Solace, the next few slides is going to be talking about specifically Solace capabilities, which is what is tapped in by the Solace Mule connector. All of the Solace and the Solace supported APIs. You can see here the traditional C, C++, Java, JavaScript, Python, Go, and then the frameworks, the JavaScript, Node.js, .NET, HTTP, Objective iOS, and there is a Spring suite, which is Boot, Cloud Connector, CloudStream, and of course native Python, native JMS, native Node.js. So there's a variety of plethora of APIs available. So whenever you're ready, you can check it out. And when it comes to connectors, when I say connectors, meaning connectors into iPaaS, platform services. So there are streaming connectors that kind of gets you to the Amazon world, Kafka world, SAP world, Oracle world, and so on. And of course, we have our native connector based on the programming language. And then there's a MQTT connector. See, if you notice the MQTT, AMQP, these are all open protocols. There are systems that's built built based on these things. So connecting with those systems will become very easy if you choose to work with the MQTT connector, right? Same thing goes for the AMQP. And Spring is very crucial for us. We use that. And of course, our own Mulesoft, Boomi, and so on. Now, in all this picture we talked about, but we never dived in, there is a queue element, right? So the broker offers you the store and forward. What does it mean? As a subscriber, you connect to the broker, you register your subscription, and then what happens if you crash or maybe you disconnected? Would the broker collect the messages based on your interest and then store it for you to deliver later, or it won't do anything? That's the question, right? Direct subscribers and guaranteed subscribers. It's a guaranteed subscribers that will mandate the broker to create a queue. So queue is nothing but a buffer storage, any way you look at it, right? So once the subscription is registered, the broker will ensure that the messages delivered on that subscribed topic will be enqueued, right? And whenever the consumer wants, they can come and connect to the queue and start retrieving. So going back again, the building block of this entire messaging is point-to-point, publish, subscribe, and request reply. And point-to-point is the least preferred, right? And I'm not going to spend time. Publish, subscribe, we already know. There are two queues. Remember, we are not even talking about consumers. The queues are created independently and slapped with required subscription. And the broker collects the published messages and enqueue them on this queue. Consumer can come and retrieve it anytime they want, right? Request reply, we know it traces back the path to the requester based on the reply to field set on the message. Okay. One of the things about EDA is it's built for enterprise business requirements. Obviously, one of the primary requirements people ask for is dead message queue, meaning message becomes invalid, other way of saying dead, on certain conditions, right? Maybe TTL, the time to live expired, or maybe there is no subscriber, or maybe the maximum redelivery count exhausted. So whatever the reason is, when the message becomes ineligible for delivery, that's what we call as a dead message. Typically, any broker would drop it, right? Unless you have a dead message queue or dead letter queue. There are different terminologies. So you will be able to configure a dead message queue for an active queue, right? So if something is getting dropped, it will be collected in this queue, all right? And message expiration, I'm sure it's a requirement, right? When you are working on certain industries, the data is invalid if it crosses a certain time boundary. Stock ticker, even the previous ticker is irrelevant when I have the latest ticker, right? So these are time sensitive. And similarly, for the currency trade, right? So the currency on the closing time is more important than what happened in the night trade, for example, right? So like that, the message can be tied with an expiry. So when the message expires, obviously, even if the client makes a request for new events, it would not be delivered by the broker because it is expired event. Those can also be collected in the message queue, dead message queue, or maybe something wrong with the connectivity. The broker delivered the message, consumer failed to receive it, or maybe connection dropped, whatever it is. So broker will retry, which is controlled by setting the property on the published side, how many times you can deliver maximum. 3 times. So 3 times I attempted to deliver, consumer is not accepting or getting rejected, then that message will also be dropped and queued in the dead matter queue. The last one quiz for the day, it is APIs are only asynchronous in EDA. Note the word. We started with the definition of EDA saying that, hey, decoupling and asynchronous are potential benefits when you use EDA. And obviously, we also know APIs, right? So what do you think about this statement? Is it a myth or a fact? APIs are only asynchronous in EDA. Nice. Yes, it is a myth, right? You can have both synchronous and asynchronous. I'll try to cover the synchronous aspect. So we're not just talking about the broker. There's also all the typical nuances, enterprise requirements, right? High availability, failover, scalability, all those things comes in. The way it works is, when it comes to high availability, you can have an active broker and passive broker, meaning when a publisher publishes to the broker, the active broker collects it and writes it into the disk, nothing but the queue, right? As part of doing it, it will also write into the redundant mate, what we call as a secondary broker. Once that write is successfully complete, then only it will send the acknowledgement to the publisher saying that, yep, I got your event. Then only it will go and deliver the event to the subscriber. So you can notice that at this point in time, if the publisher got the acknowledgement for a successful publish, you are guaranteed that even if this active broker goes down, the data is available in the redundant broker. Okay, so just a perspective. And then there is a HA and DR when the same setup is set up across multiple data centers or different data centers, right? When you publish on to a broker on data center 1, all well, before it commits or sends an acknowledgement, it goes across the WAN to the second data center and populate that in the mate, right? And the second one is the one that's going to send the acknowledgement, all right? So in this picture, what you're looking at is both HA and DR, the high availability and disaster recovery covered, all right? The last very important point is, if you think that PubSub is everything and anything except REST, no, that's not true. Don't worry about other brokers. When it comes to Solace EDA, we treat REST as a valid protocol, meaning you can have REST messaging. A REST client could be publishing event or invoke an API that can turn into an event in the broker. And similarly, a REST client could be retrieving events from the queue. So basically, PubSub messaging can be based on REST. So you can have a REST event-driven design possible. I cannot go into details because it will take a lot more time. Just to make a note of this REST delivery points, RDPs. So you can convert a REST endpoint into a publish subscribe resource on the EDA, all right? And similarly, there's also a notion of micro gateway. That means from a client perspective, you would feel like as if you are sending a HTTP GET request. But in fact, it's coming in as a topic to the broker. and it takes care of routing the message, getting the response, and then routing it back to you, right? So basically, it's a micro gateway. All right. So REST can become an integral part of your PubSub. You don't have to exclude anything. Basically, what you're getting at is, do I have to redesign my REST applications to fit to EDA? The answer is no. They can still remain REST, and they can participate in event-driven interactions. All right. Um, so this is the DMR. What we call is, we talked about Solace being multi-cloud and all those things, right? So you can have it on AWS, Azure, and private cloud, and then on your local machine. And obviously, there's one more form factor which we didn't talk about, is the appliance. See, the Solace broker is available as an appliance, a local software broker in a Docker, or on a cloud. So you can create a hybrid environment, right? So we publish from a local client via JMS to the broker, and let's assume that the subscriber in AWS is going to get that message because they're all connected in a mesh. That's called as what we are looking at is dynamic message routing. So the subscriber over there in the cloud, he doesn't even know that where the event is coming from. The mesh takes care of routing the events based on the subscription. So it's completely decoupled. You don't even know, is it coming from the same broker or different broker? Does the broker exist in the same cloud, different data center? All those things are abstracted out or are obscure to you, right? So, and then it publishes an event. Another subscriber is interested in the GCP. Sure, he gets it as well. And then a request comes from the pivotal. You see the picture, right? So this is called as dynamic event distribution. And the subscribers are talking to the local broker in their respective bounds, right? The broker takes care of propagating the subscription across the hybrid environment and takes the responsibility of routing it. This is what is called as event mesh, right? I cannot go into more details. It will take a lot of time. One last critical feature that you should be familiar with is a message replay, right? This is, again, a typical enterprise requirement. I want to replay the messages, right? For whatever reason, maybe a failure happened, or maybe you want to replay. It is quite possible. It's a configuration activity. And when it comes to replay, you can replay from a point in time, or by an ID, or again, facilities are from a specific time or origin. All right. I will take very less time here towards the end of it. Now we discussed the EDA, and we know all the details and benefits of what EDA offers, and a little bit of how Solace approaches this. When we take the Dragon board, what we have done is we have designed the Dragon board problem around the topics, right? The boat/meet/query. That's a topic on which, when you publish, you're saying basically what are the races available. And then the response comes back saying that, hey, these are the races. And then once you know the meet ID, then you can send a request saying that, hey, I want to join this race. And when the race is ready to start, the prep message comes from the broker on this topic, which is the third one, board player. So you can see here pretty much the back and forth interaction between the race controller and the clients is built around these events, more specifically around the topics, right? In the topic, some of them are literals, some of them are variables. And the variable is the one that gives you a facility, how you answer saying, how do I have multiple races? Well, each race can have its own race ID. How do you distinguish between player 1 and player 2? Yeah, each one of them can have a player ID, right? So you get the picture, right? Now, answering the first question, do you need to have a service discovery service? The answer is no. You can simply publish a query message to a known topic, and the subscriber of that topic could be responding to you with all the races available, which is nothing but our race controller application. Second question that we popped is how to signal the start of the race. Unlike a REST, right? We are doing a publish on a particular race ID, saying that the race is about to start. Boat, race ID, marks, on your marks. This is published to the broker. Pretty much, if you have 100 users, in our case, we had about 30 members, right? All the 30 members have subscribed to this topic when they launch their client application. All of them will get notified simultaneously, instantaneously, with the lowest latency that you can imagine. So for everybody, the race starts at the same time. So how to signal the start of the race? It's through topic publish and subscribe, right? And then how do you publish this row event, right? Row event is for everybody, right? So the team aggregation and then the team board position update. It is done through the broker publishes this row event to every single client out there. Again, PubSub. you can go up to 10,000 messages per second. This just from the free edition that you can get from the broker. But in real world, I think we have when this Russian war broke out, we had about 1.2 billion events exchanged in one of the capital markets, right? One of our customers. So it's highly scalable, and the message rate can be phenomenally high, right? And the fourth one, allow teammates to interact. You can create a new topic where you have a race ID and then meet ID, right? And then the color of the team. Now you are talking about interaction within a small group. The last one, how do you capture all events? The subscription wildcard, right? Subscribe to everything, boat, race, greater than symbol. Everything that's getting published, hitting the broker will be collected. You can put it in a database for offline analysis, do whatever you want, right? So that brings us to the end of the EDA overall. And I'm sure, sorry, I'm eating into Nod's time. A couple of points that I want to leave as we sign off. If you want to know more about EDA, there's an EDA Summit coming up in 2022. Please feel free to register. There's a lot of industry stalwarts on the EDA domain coming and kind of interacting, and there's a developer track, architect track, and so on. That's the first point. And then the second one is, if you want to know more about Solace, and then more specifically about the broader perspective on the EDA, there's a lot of resources available. And of course, we have training. There's plenty of free resources, training.solace.com, samples, code labs, And last piece is, just like your Mule community, of course, we are very small compared to Mule community, but it is also a growing community on Solace side. There's a lot of expert level discussion, early access to features, and insider visibility, and opportunity to connect, exchange notes, right? That's a very interesting forum. Pretty deep technical discussion happens over there. If you're interested, feel free to join. There's a benefits outweigh the time. And last but not least, there is a certification program. I mean, you can say just like Mule, but Mule is huge. I would give full respect to that. So there's a self-paced learning path. Feel free to enjoy that. At this stage, I will stop, and then I will hand it off to Nog to go through the AnyPoint connector. Then we'll take up the questions.
Yeah. So basically, when we look at the EDA methodology, like if you remember, we have Kafka, we have RabbitMQ, we have ActiveMQ. Maybe if you look at Mule methodology, it's basically the reliability approach, which is the main aspect which we look from the API process. But at the same time, when you put the entire EDA into Mulesoft, I mean, like the ideology into Mulesoft process, what we currently do. So this primarily helps in like a real-time transaction. You look at a bank transaction, which Giri mentioned about, a event that should come for the credit card transaction or a ticket booking process, or simply you order something on Amazon or Flipkart and you get the order details in some other way. So maybe the demo which Nag shows now would also cover the similar aspect. You can look at how we use the connector, what are the properties that we use, and how, what are the other ways of connecting to it. So all these details will be explained by Nag now. Yeah, please go ahead.
Thank you, Kiri. Thank you, Prithvi. Let me share my screen.
Hey guys, feel free to put your questions in the chat. Now I'm available. I will monitor the chat and help you with things.
Giri, there is a Q&A already asked by...
I did respond to it. No worries.
Can you see my screen?
Yeah.
We all know that what is Mulesoft, what is capabilities. I'll quickly, Giri already covered what is PubSub. So Solace PubSub is the first and only unified event broker that supports publish, subscribe, request, replace, streaming using different protocols. You can use any protocols like AMQ, that is and the AMQP, and Solace has their own protocols called SMF. And this, the Solace event portal enables you to discover and create, like we do APIs in our API manager, right, and design center, right? So in the same way, you can create your event-driven architecture, and you can discover, you can share it. So that is what a Solace PubSub portal. Okay, so now let's do our small business use case, guys. So let's say we have a mule cart application. It's e-commerce applications where they will it's like a Flipkart and Amazon. So we order that. So it will go to this, it will process the orders, it will charge the credit card or net banking, whatever it might be, and it will ship, it will bill that, and it will ship, and it will send in placed an order shipped. So when you use REST API approach in a microservices, what happens? See, it's a orchestrated. There is no independent, there is no self orchestration here. So you send a message, you order something, so it goes to the inventory app. Then once it reserve the product, let's say I have ordered iPhone 13, right? So it goes to the inventory, it reserve the product, and it send back response to this Mulesoft API, and then it send, and then it called billing API, and it will charge the credit card is whatever the net banking options. Then again it send a shipment. Then again again it will send a notification service. So what happens here is there is a limitations or disadvantages of following REST API approach in a microservice. For example, there are many limitations. Let's say poor customer experience. That means a customer needs to wait longer time. For example, if I order something, that is the response time is equal to sum of inventory, billing, shipment of response time, right? So all these should be response back, then only I will get a response. That is a poor customer experience. And cascading failure scenarios. For example, let's say I order something, so there is a the product is not there. So later tomorrow, if the product is came back, if it is came back, then I need to, it should send it should send a mail to or SMS to the user, right? Hey, the product is back, so it's back, stock in back, right? So that kind of features we won't fit. And lack of flexibility, right? Say for example, if you want to add any extra service like fraud detection service, then you need to revisit all the APIs, because these are the dependent APIs, restful approach, right? And poor scalability and utilization. To overcome this, we came up with this EDA approach. So when we go with EDA approach or REST APIs in a microservice, this is what, like, it's completely asynchronous. It is a fire and forget. See, I order something, it goes to the order placed queue. Let's say it's a topic, PubSub model, right? So I order something, it goes to the order topic will publish to inventory. So that is interested party, interested application. So once it reserved, once the order is reserved, then it published is reserved topic. So reserved topic is consumed by notification service and the billing service. So as soon as you publish the message to reserved topic, the message will send at the same time it will send the notification to the user saying the order has been placed, and it will start the billing. So as soon as the billing is completed, then it will publish a message to the build topic. Then it will go to the shipment API, shipment application. As soon as shipment is completed, it will notify the user, right? There is no, it's a completely asynchronous, and it's self orchestration. We call it as a choreographer, right? See, for example, we have a dancer and a choreographer, right? So there is no one-to-one, right? So the choreographer will play dance step, and all the dancers will follow the same step and in the same time. So that is what use of EDA or REST APIs. So benefits of EDA, it's like real-time customer. So as soon as you get you get some stock, it will notify immediately to the user. Increase flexibility, agility, and increase versatility, many things. Okay, sorry. Okay, so now is connector overview. Yeah. So as we are recently, last year, Solace published their connector. It's a certified Mule connector, which is Solace PubSub connector, which is available in AnyPoint Exchange. So you can simply import it, and you can work on the mandatory fields. I will cover the mandatory fields. It's like typical any other MQ connector, like AnyPoint MQ, but it comes with different features, right? The mandatory fields are the client username, client password, and message VPN and broker host. So remember, the Solace PubSub connector by default uses SMF. That is a Solace owned message protocol. So you can simply create a service here. For example, here I created a service called. Okay, so here I created a service called Solace Mule. So once you click, when you click on connect, you will get many options. For example, when you click on connect, there is it. So it says SMF, and it supports many protocols, AMQP, MQTT, and REST, right? So we use SMF. So once you click on this, you will get all the details: username, password, message VPN, and the host. You also get the trust store. You simply import your trust store and create a JKS, and you can use a TLS connection. So these are the mandatory fields. And yeah, so there is something called event portal. So as I'm not sure, like in AnyPoint MQ or any other MQs, like any other MQs like Kafka, so you won't see the underlying schemas. If, for example, we can define schemas, we can define our sample examples and everything in the Solace PubSub event portal. So to wave this schema, to wave this underlying schema, you need to enable this event portal configuration. So after you enable this event portal configuration, you will get you need to create a portal token. So you simply go to your accounts and you can simply create that portal event. Okay, so here you can user accounts and token management. Okay, so here you can simply create one thing, and you will just simply paste it. So once you paste it, so you need to select something called event portal. So here go here, and you can select whatever the features, I mean whatever the access you need, right? So after you create, you simply paste it here. I mean, with property files or something. So that is mandatory fields. And yeah, as usual, like we have a TLS connection, everything. So once it's completed, we do a test connection. Okay, so once done, that's simple. So Solace PubSub connector offers 6 operations. That is acknowledgement. Like we do get these kind of operations in every MQ connector, right? So acknowledgement, consume, direct topic subscriber, which means you can directly listen to the topic. You can directly consume from the topic itself. And the guaranteed endpoint listener is nothing but a subscriber. Like you can subscribe to your queues. And publish, as usual, you to publish your messages. And the request replay, it's like it is request replay pattern. We mostly focus on these 3. There is direct topic subscriber, guaranteed endpoint listener, and the publish. So it's a direct topic subscriber, guys. Like that means you simply you can listen, you can subscribe directly from the topic itself. So the mandatory fields are like the topic name itself, and you can simply refer your global configuration. So here, if you provide the API, if you enable the event portal in our configuration, so you will get all the details, whatever you define, whatever the events you define, whatever the schemas you define inside your event portal. So here you will get that every details. Like we get, when you create Salesforce, we get all the detailed fields, right? In the same way, when you enable this event portal, you will get, when you subscribe some queues, you will get what are the fields that is defined in particular queue, right? uh yeah. And the publish, so publish is as usual, like we have connectors like publish, AnyPoint MQ publisher, and the Kafka, right? In the same way, so you just provide the topic name. And there is something called, you can define your own user properties. For example, let's say when you process e-commerce, so we need to retain the order ID, right? So to track the order ID, so in that case, you simply define as many as user defined properties. You can define your own user properties, and it will be available entire, I mean, when you subscribe, it will be available there itself. Okay, so next I will go with this guided endpoint listener. So here it's simply like you can subscribe to the queues. And the main advantages of this Solace queue is like the subscriber is, so we can extract, we can filter out the messages based on our condition. For example, let's say I will get a status equal to order placed, right? So I will say, for example, I have a status placed, status equal to order placed, order modified, order shipped. So in these three events, I want only I want only order placed event. In that case, so you simply set your you set your user defined properties in publish connector, and here you can simply say, for example, if I place 10 orders, 10 events in the uh, queue, I can only get status equal to order placed. To do that, simply you know, it's not a data wave language or mel. It's just it's a plain text, guys. You can simply status equal to like order placed. So you can filter out based on the condition you want. So that is the advantage of this, and also it will automatically provision. If you enable this provision option, it will provision your queues. Not only queues, like it will also provision your topic. Like say, for example, you are using the queue inventory, right? It will provision a topic called, for example, if you want to do some order, it will provision the order topic and it will associate to the queues. So you don't need to go and create the topics and the topics for that queue. That's it, guys. So now I will show you the simple e-commerce business use case. What happens is, like, so whenever I place an order, it comes to this application, let's say Mulesoft application. So it will simply publish that message to order placed topic. You can see here order placed topic. So order placed topic, there are two queues, there are two applications are interested in order placed topic, order placed event, right? One is uh, inventory application, another one is notification application. We have seen we've seen here, right? See, whenever you place an whenever you place an order, there is one application interested, that is inventory application. So it receives the messages, right? So as soon as you place, it will receive the messages and it will check the message, it will check the stock. For example, if you place an order for iPhone X something, so it will check the stock. If the stock is there, if the stock is available, it will reserve the product for you. So as soon as it reserve the project, it will send a notification saying, hey, your order has been placed. At the same time, there is another application is interested, there is a billing application. So as soon as the product is reserved, the billing application will consume the messages and it will start billing. I mean, it will start charging the net banking or UPI or whatever the payment you opted for. So as soon as the billing is completed, so it will publish that message to order bill. So order build, there is one application that is interested in order build event, that is shipment. So as soon as the order is built, successfully authorized, then the shipment will start getting processed. So it will process the shipment. As soon as shipment is completed, it will publish that message to the order ship topic. So as soon as as soon as it publishes the event to the order ship topic, there is a app called notification app. So it should send a message to your order has been shipped out, right? So this is how there is no orchestration here. It is a self orchestration, right? This is called a choreography. We call it as a choreography versus orchestration. That's simple one, guys. So I will now quickly send a message. So I already deployed these microservices, like these applications in my AnyPoint platform. Okay, sorry for the noise. So here are the applications that are I deployed. So as soon as, let me publish one message. This is my message. So let's say the event is order placed, right? So I will send a message to the topic. So as soon as I send a message, let me check notification. Okay. So here I can see, as soon as I placed an order, I got a message saying immediately. It's called a user experience, right? So as soon as I get a placed order message, then I will be feel happy because I get a confidence, right? So when you go with this restful approach, what you get, you need to wait until these applications should completed their processing, right? So you can see here, as soon as it placed the order, you get a message saying like, thanks, your order has been placed and your order ID. So this order ID is like we store in a variable, like it will be there for in the all the microservices applications. So as soon as the payment is completed in it shipped, you get a message saying your order has been shipped, right? So your order has been shipped with order ID. So this is how EDA will benefit you. Will benefit you when you choose EDA over RESTful APIs. Yeah, I think that's it, guys. Quiz and any questions here?
Can you unmute yourself? It's not
Oh,
being done. Yep.
is
Sorry
it
about
now?
that.
Yeah, now it's fine. I can
Oh,
hear you.
Can you hear me now?
yeah.
Yeah, there was a question from Cinda asking, can the request having a particular order be placed or processed on a priority? I'm sure on the Mule side, you can respond now, but from a Solace side, yes, there's a whole topic of priority, message priorities. All right. All those things are accessible as a settable property in the Mule connector. Okay. So it's quite possible.
One more question. Like we have the REST connect. I mean, like REST APIs for ActiveMQ. Sorry, AnyPoint MQ, and even for Kafka also we have it. So, is there such feasibility from Solace? Or
Absolutely, yes. See, that's what I told, right? When it comes to REST, our Solace ADA supports two notions. One is basically REST as a messaging protocol, right? Like how we support AMQP, MQTT, SMF, JMS, and so on. Like that, REST as a protocol. That means you can have a REST endpoint that can receive REST requests, which in turn will be converted into a messaging request like a PubSub and can be served. So REST as a messaging protocol is one option. The other one is the entire REST. At the end of the day, if you look at it, there is a REST server, there's a REST client, right? So REST client invokes a REST request to the server and server responds. If you, in this juncture, if you think about what is an API gateway is something that you insert in the middle, act as a proxy to throttle, scale, blah, blah, all those things, right? That's a gateway. Similarly, you can build a REST micro gateway for a particular REST client server interaction where the broker can act as a micro gateway. So the client will be talking still REST, but it is hitting the broker, and the broker will proxy the request to the REST server, get the response back, and then route it as a response to the REST client. So there are two modes. So REST is an integral part. It's supported very well in Solace.
oh, okay. Giri, there comes my second question as well. So when we consider the VPCs, the load balancers, the firewalls, the proxies, all of these are on top of my entire ecosystem of my project. Now, if I am introducing Solace here, how would the latency come into picture in this aspect? Would it still be the same what we spoke in terms of the REST API methodology, or would it be impacted and reduced with this?
Not really. See, those things you would have to worry a long time back, right? Today, if your system speaks JMS, JMS is at the end of the day TCP over a port. When it comes to firewall, you just punch open a port, right? Whatever the protocol it is, at the end of the day, it nails down to some kind of a either a HTTP or a TCP port, correct? So opening up that port is not a performance impacting thing. Now, if you translate that question into if I send an encrypted payload,
Mhm.
SSL, would that have an
Yeah.
impact? That's a different question, right? So if the notice that you can have the encryption on the entire message or only the payload. And if you just take care of the payload, that's what you need to protect, right? You cannot encrypt the header because header contains topic, right? So
Right.
we are covered on both sides. To that extent, that's how we are able to offer the high performance, low latency integration broker. Yeah.
Okay. And sorry, I didn't use this connector yet, so I'm not very much clear. But Nag, maybe you can help here. What is the main difference that we can see between AnyPoint MQ connector and the Solace connector? Is it the similar way what how we connect it at the connector configurations? I mean to say.
Yeah, at the connector configuration, it's almost all similar, but it provides some extra features. Like for example, in AnyPoint MQ, right? So we are not very sure. Like we won't come to know what is the underlying structure of a message, right? So
Correct.
when you go with Solace PubSub connector, you will come to know what is the underlying schema for that particular QR message. So you will come to know what are the fields is there, and those fields you will define in the event portal. So yeah, it's almost all similar,
Okay.
and the main advantage is the event portal. So you can track,
Yeah.
you can manage everything there.
There is Nag is perfectly right. That's the primary objective. The what he highlighted, right? The integration with the event portal. I mean, I couldn't go into detail. What I mentioned is event portal is your design time aspect of EDA, right? Where you kind of break down your EDA requirements into events, underlying schema, and then group them as an application, tying down who can publish what event, who can subscribe what event, those kind of setting rules, all the way to your domain, right? So the design aspect is done, right? But from that design, how are you going to bring it to runtime? Per se, there is no need or kind of a binding this design time and runtime in the Solace context. But when it comes to connector is the one that's going to be either originating a publish or getting an event and processing it, right? That time you would care for what is the underlying schema, expected schema. You would be embarking on validation, you would be embarking on doing further processing, right? That time you can tap into the event portal and you can start by your flow design by saying that, hey, I am processing this event and I want validation based on this event schema, and I'm going to base on this access control set, and so on. So the event portal is one integration nicely happens with the new connector. That's the first part. Second part is the underlying protocol is not JMS anymore. The previous connector was based on JMS. Obviously, the Solace proprietary specialized features were never exposed. Right now, this connector is built on something called as SMF. All right, Solace. So it's a proprietary protocol, and pretty much a lot of aspects about scalability, round robin rotation, prioritization. There are so many things that you can set as a configurable property on the connector that will help you kind of realize variations in the PubSub interaction, right? You got to refer to the document. There's more than one. The priority is one that I can mention, and then the load balancing, right? Do you want to do a round robin distribution, or do you want to maintain an active passive within the connector, right? So some of the things are very useful. There is more to it.
Yeah. Thank you, Giri. Thank you. So, any other questions, folks, or shall we skip to the?
Giri, this is Suman here. I have one question.
Yeah.
I remember to answer one of the questions regarding priorities. You said Solace supports the priorities for the messaging. Is it the similar priorities as you have in JMS, or is it something different?
Uh, I mean, priority as a concept is very similar, but the implementation is slightly different. How do you control that? That interface to control that is slightly different. It's proprietary to Solace. But when I say proprietary, don't get afraid. Oh, it's going to be different. No, the interfacing, as in where do you set and how it impacts. It's all done at the message level. You can set the message priority in the properties and header and so on.
All right. So it's basically similar to the JMS priorities that we set.
Yes.
Okay. Thank you.
You're welcome. Any other question, guys?
Any other questions? If not, we can jump to the quiz part.
So one quick question is regarding the Mulesoft, like for which version it will be valid, the Solace PubSub model we have. So it will support all the version, the Mulesoft runtime.
Um,
That's a good question. Nag, do you know about this? The
Yes,
connector
so far
compatibility
I
with the
tried
runtime.
with this latest 4.3 and the 4.4 runtimes. So
4.3. Okay.
yeah, it started with 4.3, I think. 4.3 and 4.4. I'm using it for 4.4. But I will
All
check
right.
with this release notes and I will let you know.
Okay. And one more quick question. Right now, you're saying this particular PubSub connector is available in Exchange, right? Any point Exchange, we can go and check that, right?
Yes, yes, it's available. I mean, last year they have published. It's a certified mule connector, so you can download it and you can use it
Yeah,
for.
just putting the URL if you want.
I
All
just
right.
posted it.
Oh yeah, what the
And it
So
shows 4.3 as the version.
yeah, yeah.
Yes.
yeah, it seems like a couple of interesting and exciting features Solace have. But then again, we are very comfortable with the Mulesoft AnyPoint MQ because we usually rigorously use it. But today I found for the EDI, I found some of the problems with AnyPoint MQ, what problems we have and what how it's catered through Solace PubSub things. So I will go at and do some, everybody is, if whosoever interested to to check all this functionality, whatever Gri and Naga Raju is saying, like it's a very good things for us as in developers to identify which PubSub thing is best suitable for the development or our company or organization, right? So it's a very good point, Giri. You explain a lot of things, and probably in today's world, you rightly said it's everything is dynamic. You can't be, predict how the things will go, right? So we have to become with a profound solution that cater all the things.
Yeah.
And
Now,
you showed us a very good demo, even live demo we can see, and we can relate that how the things is going behind the scene, how we are catering it. I really appreciate it. You explained it, and the demo Nagaraju showed us. But there definitely there is a homework for us because it's a new things, and we will check that all the operations we have and how it will be differ from our existing solution. If it is a make sense to use it, definitely we have to go with that.
right.
And if we found some problems with Solace pops up, definitely we have to address that.
Awesome, awesome. Very well said. Thanks for the kind words. We tried our best to in a short time to get you the demo and the overview. What you said is correct. One size never fits all. Just Solace doesn't make others less, or every solution has its own place and use. Right.
Yeah,
Solace is meant for high-speed messaging (EDA). Right.
yeah,
So any integration problem, it used to be seen as a monolithic, right? If you go back in time and talk about web methods broker, BA or broker, even TIPCO to some extent, right? So they attacked everything as a simple integration as a uh, message transport. Now, with the advent of EDA, we started splitting, right? The transport is the primary focus, high speed, low latency. So to that extent, Solace stands out. Of course, Kafka is there in the same game doing a nice job. AnyPoint MQ is there. Everybody have their own niche place to play with, right? Yeah, you said it
okay.
very right. Thanks, brother.
Yeah, and one more thing, we'll get any trial version to play around this or no? Do we
Absolutely,
have?
yes. I think Nag already put that in the
Yes, yes, absolutely. You will get it's a free, even for production, I would say free. So you can go and get your free version of this.
Perfect. Now our life will be easy then.
yeah. It's a cloud version, so you are comfortable, use it. If not, you can download a software version which never expires. And if you're playing with that, again, I would recommend a cloud version because the event portal is available on the cloud and you can do a nice integration with the Mule connector.
Thank you. Yeah, that's it from my end.
Gajanan, one request. Can you help us understand what are the challenges that you had with AnyPoint MQ?
Oh, seems like as rightly said by the latency point,
Uh-huh.
Nagarjun rightly said, like we have to wait if we come across with the API-led connectivity. right? And then we probably have a different applications to call for billing, shipping, and then for what we say order confirmations, right? So we have a different, and then we have to orchestrate it, right? We have a process API to orchestrate all this thing, and then we have to, then process API will combine and respond back, right? And then again, it's all again what we see architectural point of view, how quickly we utilize our assets. It's nothing with the what we say the AnyPoint MQ, right? But it's all about how we have different assets or equipments to architect the things, and we can provide the proper solution. But rightly said by the Nagarjun, we have to wait, and we don't have the privileges to check the priority even, right? So some of the features are there, and then again I said like we have to go and do our homework, and what we can get from AnyPoint MQ, and what we'll get new from Solace, then we'll come with a proper approach. Right now it's new for us, and it's early to
Absolutely.
say make a comment on this new features. But then again, let's have a play with these
Right.
things, and then we'll come with in one of the meetup, then we'll combine all the things, and we'll see how we can utilize best suitable JMS consumer, where we have to as Gri said, right, it is more suitable for EDA, right?
Yeah,
If we'll
basically all these
mm,
products, like it's not like X or Y or Z which is the perfect one. It's all
yeah,
use case driven. So
correct,
if you look at the huge volumes, or I mean the process driven things. So
right,
if you look at reliability within the microservices, then you go for AnyPoint MQ. If you look at huge processing, then you go for Kafka. If you want a PubSub model with the proper event-driven architecture, you go for Solace. So it all drives with the process. So like you
correct,
said, we have done the previous sessions with different connectors, and now with Solace. So maybe we can plan one more session with all the three combined, and we can
correct.
drive the process, which is very good.
Ex-
Yeah, that's
exactly,
nicely.
exactly. This is what like our communities have the stuff to do. Yeah.
Thank you, Gazalan, for giving that idea because that seems really good. We can
Yeah,
plan for something like this. Sure.
correct, correct. And now there might be after once we plan that, and after that, lot of questions will be answered
Yeah,
with
right.
respect to JMS, right?
Yeah.
Yeah.
Ultimately, we just need to play around with all the connectors within Mulesoft because that's the
Exactly,
main objective here for us.
exactly. Yeah. Thank you.
Great. Thanks for the inputs. Any other questions or any inputs from other attendees? So shall we go for the quiz section? Okay, good. I don't see any answers, which I assume as S. Okay, Nag, can we go ahead for next?
Yeah, sure. Let me share my screen. Guys, it's like I will share the screen and I will show you the options. As I mean, it's like a
And
FIFO. First out, right?
basically, who fastest finger first, whoever
We do
answers it
wheel
in
of
chat.
frames. Again, it's not a. I mean, you may face some connectivity. We do wheel of frames, so we don't have a choice. I mean, we don't have a control side.
Yeah.
Let me quickly share my screen. These are basic questions. I think. Okay. Can you see my screen, guys?
Yes, we can. Yep.
Okay. So first question is how to filter out messages based on the condition. Uh, the options are using validation component, using transform message, using selectors, and none of the above.
Okay.
Okay.
Everybody answered it, and Aditya Khana. Yeah, Aditya is the winner. Nag, what is the answer?
Yeah, it's
Just for the
selected.
clarification.
It's a
Okay.
selected.
Okay. Aditya, could you please give me your email ID, and we can go for next.
Ready? The second question is what kind of message protocol the Solace PubSub connector uses by default? Sorry.
Options, please.
The options are MQTT, AMQP, and WebSocket and the SMF.
Nice. Nice to see the answers. Okay. We got plenty of answers, and it will be the first one was Shalishna.
Yes, and the winners make sure to share your valid email address. Otherwise, you will
You
lose
won't
your.
get your watches. Simple.
Yeah.
Okay, good. Let's
And
go to third question.
yeah. And the third question: how you can define or send user-defined properties? Options are set outbound properties, set user-defined properties in uh, publish connector. We can't send the user-defined properties, and none of them. The correct answer is we can set, as I mentioned, we can set user defined properties in the connector level itself. See, for example, if you want to send some custom properties, let's say order ID that should be available in all the consumers. So you define your order ID in the user defined properties, then you send it to the publish. See, for example, like, let me show you here. So this is a publish connector. Yeah, so here you can, there is something called order, I mean additional message properties where you can set the sequence number and priority, everything. So here there is a user defined properties, so there you can set the your order ID, whatever the custom properties.
Now, if we set some outbound properties before this, would it still work or it won't take those properties into the connector?
I mean before the
Yeah, before the connector itself, if I'm setting some outbound properties.
yeah, it will take whatever you receive. See, for example, if you send some headers in the request, right, I mean http requester, let's say http listener and the publish, so whatever your properties will be published to the publisher, and it will be available to the consumer.
Okay, great. So it will be Suman.
Yeah, Suman.
Okay, I got from Shaleshna. Aditya and Suman, could you please share your email IDs? You and
And yeah, thanks for joining the session, guys. I mean, after wrapping up this meetup, you will get a mail. So please share your feedback or what your next expectations are, what we lacked, so that we can improve the session more interactively. So please make sure to submit your feedbacks and
And one
share
more
your.
thing, just regarding our upcoming MuleSoft events. So we have the partner kickoff coming up in next week, which is on 24th of March. So I just posted the link in the chat. So if you are part of any of the partners of MuleSoft, then make use of this meet, because it is really helpful for us to understand multiple outcomes from MuleSoft. Even they give us the product keynotes also. So if you are someone who is interested on, see, there are many custom connectors that are coming up nowadays. And if your project requires something, but you are still doing with a traditional approach, but not with a connector, so that will be the first point you get, and you will be the first one to get that information with these product kickoffs, partner kickoffs, all these invites, I mean the meets. So it will be a very good advantage to get used with that. And another event is the Trailhead, even though it's an in-person event, but if someone is in San Francisco, then you can plan for it. I just posted that as well in the chat. So Trailblazer event is very good. You will get insights both from Salesforce perspective, MuleSoft perspective, Slack, W, whatnot. We have all the entire Ohana, Salesforce Ohana here. So yeah, that's the basic input about the upcoming events. So feel free to push your feedback please give your comments and also any suggestions for us to improve for the next meetup. Uh, so once you get the feedback email, you can please feel free to give all the details to it.
And
And if
also,
someone is interested to become a speaker in the next meetups, you can also reach out to us. You know us, and we already have the WhatsApp channels. We know the page. So during the feedback, also you can give your interest on speaking for the next meetup. So yeah, the forum is all open for you. So you're always welcome for inputs and suggestions.
tomorrow, like if you are a speaker, you will absolutely get a co-chair for training. So,
Yeah.
Yeah.
Yeah. So yeah, a quick question, Giri. One question come up in my mind, and just to let's ask. For AnyPoint MQ, it's very perfect for Cloud Hub, but when it comes to on-prem, it's always saying there is a latency because there is a cross. Platform interaction, right? On-prem in different cloud and or any point MQ in a different cloud, there is a latency there. So probably the most of the companies will not adopt that because of the latency and the performance issues there. And also it is not really recommended. But how I'm quite interested how the Solace PubSub connector will overcome this latency. What is the mantra behind it?
I mean, see, by design, these things evolved from an appliance to software broker to cloud, right? So the where we stand right now, the primary focus is multi-cloud. That's what the real customers, enterprise customers in the banking domain, capital market, supply chain, retail industry, they all go multi-cloud, because they want to have redundancy and backup, they're kind of failover scenarios, right? Very few options, to my knowledge, have mixed up this local on-prem and this one, right? The on-prem typically ends up in a design pattern like a backup. When everything fails, where do I have my last backup? In the DR, and HA perspective. I may have to get the information specifically which customer is relying on a on-prem being critical part of the mesh. We know that customers have used this as part of their mesh setup, but in an implementation perspective, as I said, right, we do not process the message in terms of opening at any point in time. It's just a blob in, blob out routing, which is at the header level, right? So that's how we achieve performance. And obviously, appropriate compressions are put in place. So our specialization comes in from lesser processing, minimalistic perspective. But beyond that, could there be any technology? I will have to look up my R&D team and get details. If you're interested, I can do that. Yeah.
Yeah, thank you. And one more question with respect to the persistence, right? Or Solace PubSub connector, where it will write the data, how it will persist it, because AnyPoint MQ is using Amazon SQS stuff, right? And then DynamoDB, I believe it's using a DynamoDB.
Again,
yeah.
The moment you say external storage, right?
Mhm.
The storage management, storage communication might be mandating its own protocol, or maybe basically two systems talking to each other, even though it is a tightly coupled queue storage for a client, right? For us, we don't do that. We don't delegate this to an external server. So when you provision a cloud broker, based on the default configuration, there's a buffer that's provisioned that acts as our storage, right? When from that, every time when you create a queue, you take a storage space, and it's configurable completely. So it's all in the cloud. For example, behind the scene, it might be S3 storage, but you don't get to know whether it's S3 or something. You see it as an extended storage of the broker, of the queue. So the access is completely abstracted, and it is highly performant because it's managed by us. It's not mediated through another DB system or anything like that. Okay.
Mhm. Right. Okay.
And Giri, in that aspect, what about the security or data related aspects like GDPR and other data restrictions?
GDPR plays at a different level, but when it comes to, based on the last question, I think I'm going to separate that. When you ask about GDPR, right, technically there is no identity information that flows through other than the access control, the user identity, who's logging in, who can publish and subscribe, right? So these are all provisions. So just like any enterprise, these are administered aspects.
Yeah, right.
So your GDPR things will be addressed if there is any conflict, any care need to be done, right? It will be taken care in the design phase, deployment phase itself. So at runtime,
Okay.
just it flows based on your configuration.
And Giri, one more question. Our AnyPoint MQ is moreover MuleSoft applications of user friendly. Like if we can use only the for the Mule application. For the non-Mule application, we have a trouble with the AnyPoint MQ to use it. So how this particular Solace will take like it will also we can use in multi languages, right? Like we can create an R APIs and a MuleSoft. We can connect in our what we say SOA we can say or .NET Python whatever language we want to
Yep.
create an API we can integrate it right
Yep.
easily.
Yep. So the point is, the way I see it is, Mule is kind of the pioneer of integration, pioneer in the integration domain, right?
Mm-hmm.
And they needed a message queuing, so they built something for internal. But again, no disrespect, that is meant to serve the internal needs of Mule, whereas ours evolved as a general purpose polyglot from the day one, protocol agnostic, cloud agnostic, language agnostic, and so on, right? So our specialization shows in that layer. But if you compare the same thing with what Mule does for the integration or message processing handling, obviously it's like apple to orange, right? So our specialization is in the messaging, and Mule specialization is probably a lot of things on that. AnyPoint MQ brings out the messaging scope, right?
Correct.
So
Yep.
our positioning is we are vendor neutral. Mulesoft is a great solution. If I expand the scope, maybe there's the ERPs, there's CRMs, or maybe iPaaS, right? So all of them could tap into Solace as a generic messaging provider, EDA
Right.
Yeah,
provider.
basically we can't compare AnyPoint MQ and Solace, or maybe Solace versus Kafka would be a good comparison, but
Good
not
start.
AnyPoint MQ versus Solace.
That's
Yeah,
right.
I'm just
Maybe we
not
can look at it.
comparing. I just like even though if you go to the documentation in the MuleSoft, they are saying these are some like challenges we are right now facing, but you never know. MuleSoft is super fast. Within a day, they will come up with the surprise. So that is the thing. I'm just you
Yeah,
asking
right.
the troubles, right? You are asking me the trouble that AnyPoint MQ. So these are the two troubles I faced when we come to use with that.
Yeah.
So that's way, yeah.
That's right.
Yeah, regarding the storage question, so
Mhm.
basically Solace PubSub use something called PubSub cache, so which uses even message event broker. So this PubSub cache can cache up to around 2 million messages per second, and can send up to six, 4 lakhs, 4.5 lakhs messages to request, the consumers.
Um, Nag, that's a very good point. I just would want to caution. The original question was the storage management, right? Behind the queue. So that storage is a regular storage tied to a queue, tied to the broker, and so on. That's an integral part of the message broker, right? But what you're referring to is a configurable thing, not necessarily that cache is there for every broker. You would have to explicitly enable that, configure that, and so on. But the moment you configure cache, obviously that is another reason for you to get a higher performance. Like what you said, right? Millions of events can be stored by the size or volume, whatever it is, right? So the cache is an optional configuration. It is not by default turned on for every instance. You would have to manually configure it. Yeah.
All right. Nice discussion. Great knowledge.
Yep. Thanks a lot for your patience and for the long discussion that we had today. Usually we won't take this much time, but today it was really interesting that we didn't even look at the time. It went around 3 hours, which is really good.
Is it
Thanks,
3 hours?
Giri, for giving the very good explanation and driving us through all the details.
Awesome, awesome. You guys are a very friendly crowd. I'm happy to be here, sharing whatever I know and some interesting questions also. So thanks for everything. Thanks, Prithvi. Thanks, Nag. Appreciate it. Thanks, folks.
Thank you, guys.
Gajan, maybe if possible, we can also plan future sessions with the comparisons that you mentioned, which we can take up further. Thank you.
Awesome. All right.
Yeah.
Thanks,
Thank you.
everyone. Have
Have a
a
good
nice
weekend.
weekend.
All right. Have a nice weekend, everybody. Thank you so much. Yeah, bye bye.